Let's talk about a security upgrade that's so big, it touches basically everything we do online. It's called post-quantum cryptography. And believe me, it's not just some software patch. It's a total rebuild of the digital locks that protect our entire world. We're going to break down why this is one of the most important tech shifts you've probably never even heard of.
All right, to really get a handle on this, we're going to walk through it in 4 key parts. First, we'll look at what this quantum threat is all about. Then, we're going to put on our codebreaker hats and see exactly how our current encryption could be shattered. After that, we'll meet the folks who are building the new quantum-proof defenses. And finally, we'll see what the plan is for actually rolling this out across the globe.
So let's dive right into Section 1, and the big one, the quantum threat itself. A completely new kind of computing is just around the corner, and it's bringing with it a challenge unlike anything our digital security has ever faced before.
Seriously, just let that question sink in for a minute. What if every single one of your encrypted emails, your bank transfers, your private messages could be cracked wide open for anyone with the right tool to see? It sounds like something out of a movie, but that's the future we're getting ready for right now.
And the tool that could make all this possible? It's a quantum computer. Now, these are not like the computer on your desk. They work using the strange and wonderful rules of quantum mechanics. And what that really means is they can solve certain types of complex problems way, way faster than even the most powerful supercomputer we have on the planet today.
And you know, this isn't some abstract problem for scientists to worry about in a few decades. The mathematical puzzles that our entire modern encryption is built on, the stuff that protects your bank account, your DMs, your online shopping, those are exactly the kinds of problems that quantum computers will be amazing at solving.
Okay, so how? How do these machines actually pull it off? Let's jump into our next section and get into the nuts and bolts of how a quantum computer can crack the codes that we all rely on every single day.
So the magic really starts with the most basic building block. Your laptop uses bits, which are basically tiny little switches. They can be on, which is a 1, or off, which is a 0. Simple enough, right? Well, a quantum computer uses a qubit, and this is where things get really wild. A qubit can be a 0, a 1, or, get this, both at the exact same time.
This mind-bending ability to be in multiple states at once is called superposition. And because of it, a quantum computer can explore a huge number of possibilities all at once, instead of having to check them one by one like a regular computer. It's just a massive, massive leap in processing power.
And then there's something called entanglement. Einstein famously called this spooky action at a distance, and for good reason. It's where 2 qubits become linked, and the state of one instantly tells you the state of the other, even if they're miles apart. This weird connection just makes them even more powerful for complex calculations.
So you've got these super-powered qubits. Now you just need the killer app. And that app is called Shor's algorithm. It was designed to do one thing incredibly well: find the prime factors of gigantic numbers. And that, right there, is the Achilles heel of our current security. Encryption like RSA is built on the idea that factoring huge numbers is practically impossible. But for a quantum computer running Shor's algorithm, it's not just possible, it's what it was born to do.
And the impact of that is, well, it's huge. Public key systems like RSA, which are used to start almost every secure connection online, are basically toast. They become totally obsolete. Even other encryption methods get weaker, meaning we'd have to use much bigger, slower keys. And the digital signatures that prove you are who you say you are online? Yep, those have to be rebuilt from scratch too.
Okay, so that was all the scary stuff. But the good news is, some of the smartest people on the planet saw this coming years ago. So let's flip the script and see how the global race to build quantum-proof defenses is going.
The answer is a whole new field called post-quantum cryptography, or PQC for short. And the goal here is pretty straightforward. Let's create new kinds of encryption that are based on math problems that are incredibly hard for any computer to solve, whether it's the one you're watching this on or a powerful quantum computer of the future.
And this isn't some free-for-all. The U.S. National Institute of Standards and Technology, everyone just calls them NIST, has been running this huge global competition to find the best PQC algorithms out there. It kicked off way back in 2016, and it's been a careful, multi-year process of testing and evaluation to make sure the next generation of security is as solid as it can be.
And after all that work, we have our first round of winners. In 2022, Mist announced its first choices. For setting up secure connections, we've got one called Crystal's Kyber. For digital signatures, there's Crystal's Dilithium, Falcon, and Sphinx Plus. Now, you'll probably notice a theme here. A lot of them are lattice-based. That's a type of math that, so far, looks to be a real nightmare for even quantum computers to solve. These are the new tools for building a quantum-safe internet.
So, great. We have the new algorithms. But how in the world do you roll them out across the entire internet without, breaking everything? Well, that brings us to our final section, the hybrid future.
The plan is not to just flip a giant switch overnight. Instead, the strategy is to use what's called a hybrid approach. This means for the next few years, our systems are going to use two algorithms at once, a classic one we already trust and a new post-quantum one. So to break in, an attacker would have to defeat both locks at the same time.
It's kind of like a belt and suspenders approach. It's all about playing it safe during this really critical transition. It gives us a double layer of security, it makes sure everything still works with older systems, and it even protects us if, and this is a long shot, a flaw is found in one of these brand new algorithms. It's just the smartest, safest way to move forward.
And I want to be clear, this is not just a theory on a whiteboard. It is happening right now. Engineers are already testing these hybrid systems in the protocol that puts that little padlock in your web browser, combining old and new keys to keep our web browsing secure.
And what's really cool is that this is a massive collaborative effort. It's not happening in some secret lab. You have projects like Open Quantum Safe that are creating free open source tools so that any developer anywhere can start experimenting with and implementing these new defenses. It really is a global team effort to upgrade our security.
Look, we are living through one of the biggest cybersecurity transitions in history. There's a quantum storm brewing on the horizon, for sure, but the world's top cryptographers are already building the shelter. The very foundations of our digital lives are being rebuilt and reinforced as we speak. So the only real question left is, are we ready for what comes next?